So good morning दोस्तों. Today we are going to start about the magnetic effect of current. So before starting the magnetic effect of current, we'll go to review about the currents and the heating effect, and after that we'll go for the magnetic effect. We'll discuss about the magnetic effect, how the current can produce the magnetic field, and how the magnetic field can produce the current in moving conductor device. So these are the few phenomena in the magnetic effect of current. We'll study about the Fleming's left hand rules. We'll go about the how the magnetic field can be generated, the what are the effect, how the north pole and south pole we can calculate. So these are the details about the magnetic effect of current in your syllabus. It's lots of things there in the electromagnetic field theory. This is also part of the magnetic effect of current, but this is that electromagnetic field theory is not coming in your syllabus. We'll little bit only the basics, how to explain about the magnetic effect of current. We'll only go about that. So coming to the chapter, the magnetic effect of current, let me ask you some questions. So what is actually the magnetic effect of current? So you can see now, whenever you can see, whenever suppose this is a conductor, okay. So whenever the current will pass through this conductor, na, this conductor will produce the magnetic effect, okay, and this conductor will treat as the north pole as well as the south pole. So we'll discuss about the in enhanced way, but this is the exactly the magnetic effect of current. And the same way, vice versa, when the magnetic field is there, when a conductor will move in that magnetic field, when suppose this is magnetic field, when conductor will move in that magnetic field, in such scenario there will the current production produce inside the conductor. That current will be look like the current produced by current produced by the magnetic field. So it's the vice versa. So what happening here, the current can produce by magnetic field or current can produce the magnetic field. So you should we should go in detail about the how the magnetic field can produce the current and how current can impact on the magnetic field. So before starting the magnetic field, I just want to say the heating effect of current. So in last topic we had a study about the heating effect of current. So what happening here, when there is a resistance R, when the current I is passing through resistance R, the heating effect, the power generate, power, I am not talking about the energy, the power generate equal to I square R, and the total heat produced equal to I square R into T, power per unit time, and the total heat generate I square RT. So this is the heating effect of current. So for the heating effect of current, this formula clearly show that for heating effect we must have what we must have, we must have the resistance, we must have the current, and after passing the current in the resistance for the time, there will be the production of heat. That heat will be the I square RT, and the power equal to I square R. Okay, okay. So let's come to the point. It's all about the heating effect. Now coming to the point, to previous chapter, the electricity, we learn about the heating effect of current. That is written here. Your line is written. What they are explaining about in the previous chapter on the electricity, we learn about the heating effect of electric current. What could be the other effect of electric current? That will be the magnetic effect of current. So we know that the electric current carrying the wire looks like a magnet. So how we can check this? So there is the checking system there. uh, how we can check this? So we can do one thing. Suppose there is a wire here. This is the wire, and the current is passing through that particular wire because this is the positive, so current will go in this wire. Okay. So when current will go via this way, what will happen? This way, when the current will go in this way, what will happen? When we put a compass here, there will be the deflection in the compass. So there will be the deflection in the compass. Actually, that deflection, how that deflection will happen? The region of the deflection is, so the region of deflection is because of the current passing through through a conductor. There will be the magnetic effect, field produced by that conductor around this conductor, and the compass needle will be get attracted by that particular magnetic field. So this effect is actually called the electromagnetic effect of current. So what actually is the electromagnetic, not is the magnetic effect of current. The movement of the electron is called the electromagnetic effect. And who has discovered this? The Hans Christian Oersted. In this is the scientist. He is the scientist. This scientist created the technology such as on the basis of magnetic field. They have created the technology for radio, television, and all. So the entire antenna is actually working in the electromagnetic field theory. We'll discuss about, or maybe you will learn these in the next class. In the 11th or 12th level, you will learn about that, the electromagnetic field theory. So let's go to the next level. So what will happen uh, when we'll put a magnet here? This is the magnet. When you will put a magnet, what you will see there, the iron filling. So what will happen? And the small iron pieces will put on the table and will put the magnet. So you will see the entire iron piece will be the aligned themselves. So when we'll put the iron pieces near to the magnet, so the entire iron pieces will get self-aligned. And we know these iron pieces are the having some mass and some volume, so they will only self-arrange. They will get the some external force from the either the human being or maybe due to the that device, that particular you can tell the magnet. So this the alignment and the arrangement of this iron is because of magnetic field. So the iron filling arrange themselves in the pattern as shown in this telling about. Why do the iron filling arrange in such a pattern? What does the pattern demonstrate? The magnet magnet extracts its influence of the region surrounding it, and therefore the iron filling experience the force, and the force thus extended make the iron filling arranged in the pattern the region of the surrounding of the magnet in such the force that magnetic can be detected is said to have the magnetic field. The line along with the iron field align themselves with respective magnetic field lines. Okay, so we can't see the magnetic line. Nobody can see the magnetic line, actually normal eye. So how we can find out that this is the magnetic line? When we are putting the magnet, and suppose this is the magnet, you can write a north pole and south pole. So when the iron is getting aligned, you can see this. So we are assuming that because of there is the force that attracting the iron, so because we can assume that these are the magnetic lines. We can't see the magnetic line, but we can imagine how the magnetic line will be look like. So the according to the iron arrangement, we can tell about the magnetic lines, and the magnetic lines intensity will be less when we'll move from far distance from the iron to this. So when we are drawing the magnetic line, this, so how it will be look like? Magnetic line will be always from north pole to south pole. So when we are drawing the magnetic line, it should be look like this, north pole to south pole. Whatever it will be, it will go to north pole to south pole. Don't think it's open. Every line should having the loop, and this way. Whatever the magnetic line will be, that will be actually generate from the north pole, and that will be go to the south pole. Okay. Okay. Now coming to the next level. The magnetic field is a quantity that has both direction. So guys, it's the very important point. Magnetic field that has both direction and magnitude. The direction of the magnetic field is taken to be the direction of which a north pole of the compass needle move to inside it. So direction of the magnetic field in which the north pole of the compass needle moving towards. Therefore, it is taken by the conventional that the fields of the line emerge from the north pole and merge to the south pole. That I have already shown in the figure. Emerge from the north pole and merge to the south pole. Okay? And the direction of a field line from the south pole is to north pole. Thus, the magnetic field lines are closed curve. So, the magnetic field line must be a closed curve, north pole to south pole. The relative strength of the magnetic field is shown in the degree of closeness and the field lines. The field is stronger, that is the force acting to the pole another magnetic place is greater, and the field lines are curved, crowded. So what we are trying to say, the field lines, the intensity of the field lines will be high, and when we'll go the distance, in such scenario, the field line, the intensity will be less. Yeah, definitely, because it take the large distance, but the line count will be the same. Okay. So it's all we have talked about the magnetic field. So now coming to the magnetic field due to the current carrying conductor. So we all know the conductor is only current carrying. So the current carrying conductor can produce the magnetic field that we will discuss here. We have seen that the electric current through a metallic conductor produce a magnetic field. So a metallic conductor that having the electric current or electric current passing through the metallic conductor they will produce the magnetic field around us. In order to find the direction of the field produced, let us repeat the activity and follow the way. So this is written here, the how to find out the magnetic current directions. So it's a very simple. No need to actually go and lots of discussion here. It's the very simple. Whenever the current will pass a simple electric circuit in which the straight copper wire is placed parallel and over the compass needle, the deflection of the needle becomes opposite when the direction of the current is reversed. So you can see now, when the direction of current is this direction and when our direction of current is this direction. So what happening here, when the direction of current is this direction, the needle will move this side. When the direction of current is this direction, the needle will move this side. So what happening here, so this is the actually showing the direction of current as compared to the movement of the needle. Okay, so the change of the direction, so what we can say, the change in the direction of the needle, you will see that now a needle movement opposite direction towards the current, when the current direction has been changed. So this is the actually the effect of current produce the magnetic field, and due to this magnetic field the compass needle. So the measurement of the best way to measure magnetic field is, you should take a compass, just take a compass, put where current carrying conductor, and see the reflection of the compass needle according to the flow of current. And how you can change the direction of current, just change the direction of the battery. So after changing the direction of the battery, the direction of current will change automatically, and accordingly you will see the movement of the compass will be the reverse. So this is the magnetic effect of current. And how we can find out the entire things. So the best way to find the direction of the current, direction of the magnetic field also, that we have already talked about the magnet, they having the magnitude as well as the direction. So this is the question, this is very good point. So the direction of the magnetic field will be, how, suppose this is a cardboard. If you consider this scenario like this, and this is the conductor copper coil that is passing through the cardboard, and the cardboard having the one plane, and what will happen when the current is passing through here, there will the magnetic field that will produce on the perpendicular of the current, that is the magnetic field, correct, that is the magnetic field. The magnetic field will be produced when they will be passing through here. So this magnetic field will look like, it's a very good concept, you should understand. So the magnetic field will, how they will look like, so the magnetic field will be look like this circle, this. So and the current is perpendicular, is the plane of the cardboard, and current, where the current will be the perpendicular of this. So it's a clear that the magnetic field and the current, whatever the current we are passing through the conductor, the magnetic field produced by that particular current, will be the perpendicular to that particular current plane, or you can tell that the current will be the perpendicular to the magnetic field, or magnetic field will be the perpendicular current. So this is the value, and the same way this is the moving this side, because what happening here, I have already told you, when you will put here one compass, if you will put here one compass, the the needle will move in this way. Okay, so that's why we are defining the magnetic field in this way. And when the current will push in this way, the needle will move in this way. So in such cases, we'll consider this way. Okay. So the entire conversation is talking about how the magnetic field will be look like. So it's clear that when we'll discuss about any of the devices, and when we'll go there, we must aware about how we can find out the magnetic field as well as the current. So you should put your thumb in the current direction, and you just hold this and just turn your finger in this direction, you will get. So the current will be this direction, magnetic field will be this direction. If the current will be there, if the current will be this direction, in such scenario the magnetic field will be in this direction. So you should aware about the right hand thumb rule. So when you will go and suppose this is the current, this thumb is our current. So when we'll thumb, and we should just consider this is our conductor. So when conductor and current is passing in this direction, when we'll this close this is the current direction, this is the magnetic field direction. So our finger, the rest of the finger will be help as the magnetic. So magnetic direction is the right hand thumb rule. So finger will be look like the magnetic direction, finger, our rest of the finger, and what will happen, and the conductor carrying current, the thumb will be in the what direction? Current direction. So you should always remember and find the direction of the current as well as the direction of the magnetic field. Okay. So this is telling all about. Now coming to a circle. Initially we have talked about a simple straight wire. Okay. Now coming to a circle, you will see if a wire is the loop, and what you will see now, this way the current is flowing. So the magnetic current will be this direction, this direction, this direction. Half the magnetic current will go in this direction, and half will be go in this direction. So actually what happening, you should just take a small part, and you just consider a part of that circular, just take a small part, just consider is the current is passing through. So in current is passing through, the magnetic field in this direction, suppose. So same way, when the current is this upper part, the magnetic field will be this direction. So the direction of the magnetic field in different way, different type, and in same way we will consider we all know the North Pole is actually generating the magnetic lines. So whatever the direction of the generation of the magnetic lines, that will be the North Pole, and the opposite will be the South Pole. So when we'll go in this study and just read these all things, we'll understand everything easily. But the process is, they are just considering this circle as a small rod, and each and every small rod, actually they are making a circle, and each and every small rod, small rod will create the magnetic field, and that magnetic field will be the direction of the magnetic field, the North Pole and the South Pole will be the way of the circular wire, how they are representing here. So this rule is called the Maxwell rule. So let me read the entire things properly so that you guys should go and again revise it properly. So we have far observed the pattern of magnetic field line. We have far observed the pattern of magnetic field line produced in a current carrying straight wire. Suppose the straight wire is bent into the form of circular loop that I have already told you. The current is passing through it. How would the magnetic field lines look like? We know that the magnetic field produced by a current carrying a straight wire depends inversely on the distance from it. Similarly, the every point of the current carrying circular wire, the concentric circle represents the magnetic field around it and would belong the larger and larger as you move away. Okay, by the time of the reach at the center of the circular, the arc, that big circle would be appear at the straight line. So circle के बीच में जब आप जाओगे and this will be the look like the straight line, लेकिन when we'll move towards, it will be the curve. So every point on the wire carrying the current will give the range of the magnetic field, appearing on the straight line in the center of the loop. By applying the right hand thumb rule that I have already explained you, the right hand, it's easy to check the very section and wire contribution on the magnetic field lines and the same direction within the loop. So this the entire process is actually the Maxwell rules. Okay. The same way they had explained about here, the not a single loop, the many more loop is here, and the same way they are explaining about, I am coming that point also. Okay, coming to the next point, the many more loop will be here. Suppose many more loop, if we will use the many more loop, the magnetic produced by the current carrying circular coil, the many of there, so that will be the higher. Okay, so for the solenoid, this carrying solenoid, I am talking about this solenoid. Now coming to the solenoid, so in solenoid, if you see now, all the magnetic field inside the solenoid, entire solenoid, will be uniform. Okay, so inside the solenoid the magnetic field produces uniform, and outside the solenoid will decrease when we move from solenoid to the distance. So this they are talking about, and if you go there you will understand the entire things easily. Okay, force on the current carrying conductor, अब ये भी समझना, it's very easy. So when you will, a current carrying conductor, suppose this is current carrying conductor, and when you will put that current carrying conductor inside a what is this, magnet. So when we will put a current carrying conductor inside a magnet, we will see the deflection on the deflection or displacement of the current carrying conductor. The displacement of the rod is above actually suggested that the force is exerted on the current carrying aluminum wire when it is placed in the magnetic field. It also suggests that the direction of the force is also reversed when the direction of the current through the conductor is reversed. So that point I am talking about. The direction of the current through the conductor is reversed when we will change the direction of the current. That we have already discussed in when we are applying the compass there in magnetic current carrying conductor in front. Now change the direction of field vertically onwards and everything will be the change. So this explains actually the Fleming's left hand rule. We consider the direction of current and the magnetic field perpendicular to each other. ये हम लोग पहले भी देख चुके हैं कि direction of the current सोचो अगर ये आपका y एक्सिस होगा, ये x एक्सिस होगा, तो ये होगा आपकी z एक्सिस. Z एक्सिस मीन्स परपेंडिकुलर. सो द फोर्स 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 जो होगा, अगर इसको आप फोर्स बोलोगे, एक्स एक्सिस को, वाई एक्सिस को अगर आप मैग्नेटिक फील्ड बोलते हैं और इसको अगर आप करंट बोलता है, तो वाट एवर द फोर्स विल अप्लाई ना, दैट विल बी द परपेंडिकुलर टू द field, magnetic field, as well as the current carrying. So the everything's thumbs motion, this finger field, magnetic field, and this is the current. So whatever the current, this way you can see. So this is the current, this is the magnetic field, and this is the force. So the force applied on that particular device or the current carrying conductor will be perpendicular to the magnetic field as well as the current. That's the Fleming left hand rule. So you should understand about that. What is the Fleming left hand rules? And you should go there and little bit explain it in your own language. But the actual scenario is the Fleming left hand rules is when we'll put a suppose when you put a current, this is current. Suppose if you assume that, or you can assume this is the current. Sorry, thumbs is here is showing the motion. So if this is current, this is the field applied. So the motion, if this is the thumbs as a motion, so the thumbs motion of the device is perpendicular to the force applied by the on the device, and field current, that current force is the motion, and the field applied and the current the perpendicular, these three are perpendicular to each other. That is the Fleming's left hand rule. So you should write the Fleming's left hand rule. This is the important, and you should write it in your own language, and you should remember this in future. So a little bit explain about the domestic circuit here. The domestic circuit, the same way we can see here. In our home, we receive supply electric power through the main supply called the mains, either support through the overhead electric pole and the underground cable. One of the wire in the supply is usually red insulated wire. The call wire is the positive. Another wire with the black insulated is called the natural wire. In our country, the potential difference between the two wire is that we all know. The potential difference between two wire is 220 volt. That is the 220 volt, black and red wire. At the meter board in the house, these wire passes in the electric meter through the time fuse. Through the main switch, they are connecting to the wire, and these wires supply electricity and spare the circuit within the house. Often two separate circuits are used. One of the 15 ampere current rating application, the higher power rating and air cooler, and the other circuit is 5 ampere that the bulb fans and it. The earth wire, which is insulated in the green color, it connected to the metal in the deeper earth near to the this use of the safety measurement, especially for those applications, and the metallic body is connected to the earth, which provide the low resistance conducting, and thus the insulation. This is the metallic body. Why metallic body connected to the earth? That is providing the low resistance, and that the passing the leakage current. If the ensure that any leakage current in metallic body, I have already told about the leakage current. So my request to all of you now, so go and just make the diagram of domestic electric circuit. That is important for your exam. How the domestic circuit. So 3-4 points we have studied here. The domestic circuit diagram that I am showing here, you should go and just read there. The domestic circuit diagram. Another will be Fleming's left hand rule, another will be the Maxwell rule, and another will be the how the magnetic effect of current is look like. So these are the 3 4 points that will generate the questions, and you should go and practice the question. Whatever the issue will face, na, please raise your concern. I am here for making your doubt clear. So that written here, the measurement and all the whatever the we are doing the precautions, no? That precautions. One is the fuse, another is the earthing. So just read these that I have already explained here, and just understand the entire things. Okay. So the earthing will be the entire device will be the earthed there, and the one is the live wire, and here is the neutral wire. This is the black, and this may be the red, that will pass through the meter, and after coming to the distribution box, this is the distribution box. From here we are passing these things, the live and in, and earthing will come directly, that will not pass it through the distribution. Yes, maybe the distribution box will be connected with earthing, but that will not, earthing will not come and pass through the distribution box. So the entire magnetic effect of current we have explained here, and you should go and practice all the questions, and whatever the issue will come, please raise your concern. So thank you from my end. So let's wait from your end for your response. Thank you guys. Thank you.